Honky donkey substitution. So what are we doing here? We are essentially reversing chain rule. So those of you who are sharp with chain rule will recognize maybe right off the bat that this is going to be negative cosine x squared plus c. Okay, but that's not a really systematic way of doing this. So we're going to develop a systematic technique to reverse chain rule. So I'm going to go through some examples and teach that way. So the first thing I'll do here is choose what's called the inside function. Where did my screen go? Oh boy, I lost it. Oh, there we go. Sorry. So if I look at my integrand, the inside function is clearly this x squared thing here. So I'll do that. The next step is to take a derivative. And then finally, I will solve for dx. Okay, recap. Choose inside function, take a derivative, and then solve for dx. Now I'm going to take the first thing and the last thing over here and plug it back into my integral, giving me 2x sine u and then du over 2x. And quite nicely, the 2x's cancel. And I get sine u du. Hope you'll agree this is a much simpler integral. In fact, I just used my memorized formula to get minus cos u. The original integral was given in terms of x, so my final answer should be given in terms of x. Like so. Okay, you'll notice that, excuse me, I have reverse chain rule. You'll notice that, what else? This plus c, it's okay to just throw it in your last step. You don't have to do it here when you first find your indefinite integral. Okay, another example. So here we go. Something with no trig, but still we have an inside function. 1 plus x squared. Oh, why does that always happen? So I choose that. Okay, it won't always be this easy. But to begin with, it is. Take a derivative. Solve for dx. Okay, just like before, the inside function here gets replaced with u, and the dx gets replaced with whatever I found down here. Okay, nice cancellation again. And I get u to the 9 over 9, which is 1 plus x squared over 9. Bada boom plus c. Looks good. Okay, so that's the basic outline of the technique. A more formal demonstration of the validity of this technique you can find in the book, or you can ask me about. But the basic outline is you choose a u, you take a derivative, and then you solve for dx, and then you plug this thing. You plug this thing. No. You plug this thing. This u goes here. And then this guy over here ends up right there. Now, let us try a couple exercises to practice. So here are the two exercises. Once you pause, copy, and try. And the answers are given there in green. So pause, copy, try. And ask me during class if there are any headaches. Okay, let's do some more complicated examples. Something with a square root, x over. This one's not too bad. It just requires a bit of algebra with the square root. Okay, so let's see. What do I want to do? I chose the inside function, what seemed to me the obvious inside function, 1 minus 4x squared. You may sense a bit of difficulty here because why did I not include the square root? Well, that takes some experience. Unfortunately, integration is not so simple as differentiation. There are choices to be made. There are differences of opinion. But in differentiation, it's just some simple rules. You apply them, you're done. But in integration, it's not so easy. Minus 8x for my derivative. Dx is du over minus 8x. Okay. Use my two circled things to simplify my integrand. Okay, a bit of algebra here that trips people up. Okay, this minus 8 should move out front as soon as possible. It ends up like so in front. And then the x's cancel. Okay, I want to use the power rule. So I need a power. So I take the 1 over square root u, write it as u to the minus a half. And I continue on with my power rule. So what's that? Negative 1 over 4 u to the half, which is equal to, well, plugging my u back in, I get this. And that looks good to me. Okay, you'll maybe have noticed already this 4 here. Sometimes it stays out front as a fraction, or you could, if you wanted, you could take that 4 and put it underneath, here. I don't have a preference, whatever you want. Okay, let's try a tricky example. X over 1 plus x to the 4 dx. Now, perhaps the most obvious, the choice that jumps out at you is 1 plus x to the 4. There is a problem with this. What is the problem? Well, let's look up here to see why I was happy up here. So look at my red circle up here. I'm happy here because my x's are canceling perfectly. Okay, you must not have mixed variables. Okay, when you come to this stage, you want to have just a single variable u. Okay, if you have mixed variables, you are in deep trouble. You have either made a mistake or you have chosen your u poorly. So mixed variables in this class are a very bad thing. So when I look down here, I can see that this 4x cubed, what's going to happen with it? Well, let's just take this to the bitter end here. Okay, I'm writing in red here because I'm going to erase all this stuff in red. Not good. Okay, I'm not going to be able to get rid of my x's. Okay, another name for substitution, another name for this technique is a change of variables. So we're trying to change a variable. We're trying to arrive, like we did right here, at an integral in terms of a different variable, a simpler integral than the original, but completely in terms of a new variable. Okay, there's no more x. So that's what I would like here. It's not happening. So I would say mixed variables equals unhappy face. Unhappy face. Now, I need some motivation here. I need some idea that will help me choose a good u. Well, why don't I just say, well, what do I want? What do I want to have happen? I want this x here to go away. This x here. How can I make that go away? Well, I can make it go away if there is just an x down here. And how can I make that happen? Well, I can make that happen if I go u is equal to x squared. Okay, because now I'll have just 2x in the bottom. I'll get the cancellation I want. I don't yet know if it's going to work out entirely well, but I'm at least motivated to keep going. It is something. Okay, sometimes in math, you just have to plow forward and hope for the best. Okay, less talk, more rock. What's happening here? What's going to happen to this x to the 4? Oops. It's going to become, that's u squared, right? If you look at, if I square both sides of this equation, you get that. Now something good has happened. I have half 1 over 1 plus u squared du. And that's a half. And this is a memorized formula. This is arctan. So half arctan x squared plus c. Okay, so that was not easy. This doesn't happen very often, but sometimes you have to make a clever choice for you. Okay, a couple exercises here. Let's see. I think the second one will be tricky. Okay, pause, copy, and try those two. And in the next video, I will look at the second one.